afternoon, all of you. I am Moumita Ghosh, currently working as Assistant Professor in the Department of Information Technology. Today, I will explore the topic problem solving in artificial intelligence. Let's start it. Now, what is problem solving in AI? In AI, the term problem solving is given to the analysis of how computers can be made to find a solution in a well circumscribed domain. Now, the question is, what is well circumscribed domain? Well circumscribed domain means in the domain which is having some explicit rules. These are often used to explore the ideas in AI. A good example of problem solving domain is the Tower of Hanoi puzzle, or it could be tic-tac-toe problem. These are the all well circumscribed domains problem. Now, what is the approach that an AI you solve the problems? Problem solving is defined as the way in which the agent finds a sequence of action to achieve its goal when no single action will do. So what we understand from this, that means every problem is having some start node, or which is the initial state, and we will have the goal state. So we have to reach from the initial state to the goal state by some intermediate state. So if we apply our rules, so we can reach from one intermediate state to another intermediate state. So ultimately we will have to reach the goal state or goal node. That means an agent has to execute not a single action but a state of action in sequence to achieve the goal. That means it is not possible for an agent. If we apply a single action, we are not able to reach from the initial state to the goal state. If we want to reach from the initial state to the goal state, we have to have apply some of the actions so that we can reach from the initial state to the goal state, as it is written in the slide. Next. Now there is an algorithm. If we apply such algorithms, we will be able to solve the problem. Now, any one algorithm for a particular problem is not applicable to all types of problems. In a variety of situations, so there are n number of algorithms are there for problem solving. So what are the different strategies to solve the different type of problem? At first, what is our agenda? At first, we have to analyze the problem. So after analyzing the problem, we have to find out the data about the starting state and the goal state. Now, which is called the initial state and the goal state. Then we have to analyze some production rule from the initial data set. This is present. The rules are already present in our knowledge base. So that will be progressing of the problem from the initial state to the goal state. Select some of the rules from the set of rules that can apply to the data. Now it is not possible for all the problem, or it is not justified that if we apply all the rules in a particular state. As per the situation, we have to apply the rules in a particular state so that it could be reached to the either goal state or any one of the intermediate state. Next, apply those rules to the initial state and proceed to the next stage, as I have already said to you. Next one is the determine now some newly generated state after applying these rules. Now after applying each and rule, some of the new state will be generated. Accordingly, make them as a current state. Now what do you mean by the current state? Current state means the newly generated state. Now if we now want to apply any of the rules, we have to apply the rules on the current state only. Last one is the finally achieve some information about the goal state from the recently used current state and the goal state. So last, whenever we reach to the goal state, we can exit. So if we apply the aforementioned rules, and user may get the solution of the problem. So these are the common algorithms to solve any kind of problem in an AI. Now already I have discussed which kind of problem is solved in the AI. Now problems should be well circumscribed. What do you mean by then? Again, I am telling that every problem is having initial state. Every problem should have one goal state or more than one goal states may be possible in some cases, and there should be some definite rule so that we can apply any of the rules so that we can reach from the one or progress from the one state to another state. Now let's say it. Now these are the well stated some terminologies, well coined terminologies which we often say. Now this is the state. State is nothing but the configuration of the game at any point of time. Now if it is game, if it is not game, then if it is the we can say configuration of the problem at any point of time. Now what is state space? Now description of all possible states reachable from initial state. We form the graphs, nodes. Generally, if the problem is defined in terms of graph, then the states are called as the nodes, and the accents are defined in terms of the edges. Now, the problem is having initial state, which is nothing but the initial node. We will have the goal state in the graph. We will say that this is the goal node, and we will have the path cost. These are the production rule. Now, what is the production rule? Production rule is nothing but the sum of the rules which can be applied on the current state. So, result into the next state. So, if we apply the rule on the current state X, we will get the new state as Y. So, where LHS represent the current state in the problem space, where HS is the resultant state. Now, next is the problem production system. Now, AI system developed for the solution of any problem, component of any production system. In the production system, we have to have production rules, we have the knowledge base, we have the control strategy. Now, what is control strategy? Control strategy means order in which rule is applied compared to database and knowledge base rules. That means there could be some rules, but in which order we are going to apply, these are the control strategy. And last one is the rule applier. Checks current state with LHS of rules in the knowledge base and find appropriate rule to apply. Next, see, this is the eight puzzle problem. Now, is this a well circumscribed problem? At first, let's judge it. Now, yes, it is a well circumscribed problem as it is have an initial state we can see in the left, and it will have the it should be the goal state written over here. It is the goal state, and it will have some rules or operators and actions. Now, what are the rules to play the game? See, in the eight puzzle problem, there is a blank tile, and this is a 3 cross 3 matrix. That means we can move the blank position up, down, left, and right. So these four thing is written in terms of the axis. It is written move blank tile up, move blank tile down. It could be move left. It could be moved right. So how to do it? So what is the search technique over here? Now we have the search technique that we have to reach from the initial state in the final state or the goal state, which is written in the goal state. This should be goal state instead of initial state. This is goal state. Now how can we achieve it? Now the problem formulation, as we have seen in the problem solving, at first we have to solve the problem. Now if we solve the problem, it is nothing but 3 cross 3 vector used for the board. Blank tile is represented with B. Number tile are represented with corresponding this number. That means B is justified for the blank tile. Now this is our initial state. Now see the tree-like structure that from this point, this is my initial state. I can see if this blank tile B, the pink in color, is moved in the middle, that means whatever the number present in this particular tile, it should be moved in the right position. So see how many rules can be possible. So from this position, the tile can be moved left, this tile can be moved up, and this tile can be moved down. So from the initial state, I can have generated, we can have generated maximum 3 possible states. So this, if this is my initial state, so these 3 are the intermediate state as generated from this particular state. So after generation of these states, I can see that the position is being moved here middle, here up, and here the downward. Now every time these intermediate states are also capable of generating some of the in intermediate states also. Now whenever one intermediate states have been generated, it is matched with the previous with the goal state or not. So what is our goal state? Our goal state is 1, 2, 3. This one is my goal state. So whether this state is equal to this state, yes or no? At first, every time this will be checked. If it is not, yes, it is obviously it is not. So if it is not, it will be again generate some of the intermediate states. It will apply the rules in the form of action. Now again, as the pink, the blank tile is in the middle, so again another four states could be generated. So these are the four states are generated from this particular intermediate state. So right now this intermediate state is my current state. So if it is generated, then 4 should become over here, and if it is moved to the left, then this state is generated. If it is moved to the downward, then 3 is placed over here, and this is generated. If it is right inside, then this will be generated. So similarly for this position, we can see two further states could be generated, though it is not seen in the diagram, but you can well understand is this, that the two states should be this pink blank tiles will be moved to the leftward, and blank tiles will be moved to the downward. So another two possibilities here also, we will have the two possibilities. This is also in the coordinate position, so it could be moved in the upward direction, or it could be moved in the leftward direction. So again we will have the two states further over here and two states further over here. So again another, we have some intermediate states we have generated from this particular intermediate state. For this another two, for this another two. So let's check, is this my goal state? So let's check with verify it. No, this is not my goal state, this is also not my goal state, this is not, and this is not. So again further we will consider. Again there is also three possibilities, so three substring, so three substate or three intermediate states will be generated from here. From here also we will have generated three another intermediate states. Here also we can generate three further more intermediate states, and here also we will have the three further more intermediate states. Finally, after applying this rule over and over, and some intermediate states will be generated, and every time we will verify it with my goal state. So finally we have reached to this particular position which is given as the goal state. So whenever we reach to the goal state, we terminate. That means we have achieved the goal state. So what is our path? So path is from this initial state. At first we have reached to this particular intermediate state, and from this intermediate state we will have to reach over, we have reached over here, and from here to here. So after 1, 2, 3, after 3 time steps, we are able to reach from the initial state to the goal state. So this is the way how we used to solve our problem in a well circumscribed domain. Clear, all of you? Now next is the, if we conclude what is search process contains, the search process is nothing but expanding a node, generating a node, comparing, tracking the path and path cost. As I explained in the earlier example, yes, we are exploring or expanding certain nodes, or it could be we are generating certain roads. Then every time we are comparing, what we are comparing, that whether we have reached to our goal node or not. If it is not, then we will regenerate or re-explore or expand the nodes, and ultimately we track the path and determine the path cost. So next. This is another example. The example is the tic-tac-toe problem. Now this is a very well known famous problem. Now this is a very, this game is known to all of you. Now see what is the initial state. In the initial state, all the position. Now this is the again 3 cos 3 matrix, or 3 or 2G array. We can define this as a 2G array. So two players will play the game. One player will mark the, one player will mark with a cross, and another player will mark with a 0. So in the initial state, all the positions are vacant, and it could be, or it could be filled with the 0, no problem. So here these are all my goal state. So the goals here you see there is not a single goal state. There could be more than one goal state. So whenever a player reach any one of the goal state, any one of the possible goal states, the problem will terminate over there. So here our objective is to reach from a one particular one initial state to any of the goal state. Now see, this data structure is now how to formulate this kind of problem. Now this kind of problem is formulated using a data structure of 3 cross 3 matrix. Now blank cell is represented with this symbol 0, cell with X or cross marking represented with the player 1, and cell with O marking is the player of the player 2. So this is my initial state, and this is the one of the goal state. So see how we are playing that 1 1 1 means, that means these three positions is occupied by the player 1, and as this is a valid rule to terminate the game, and we declare the winner of the game as a player 1, to see that these three position is occupied by the player 1. So this is the scenario. So thank you. Next day we will discuss what a jug problem. This is another important problem.